Great. Stream should be transferred over. If you're in the YouTube chat, you can let us know that you can hear us. Here's the agenda. Slightly mixed up things today because we had a DevNet launch this morning. So Altair DevNet 1 launched this morning, 2 hours ago. The fork happened about an hour ago. Perry, you helped coordinate and run that. Can you just give us and the people on the internet an update on the status?
Yes, so Altair DevNet 1 launched about 2-ish hours ago, and we forked at Epoch 10. We seem to still be finalizing and are hovering around the 80% participation rate. So still figuring out some issues with the client, but we seem to be doing okay.
Cool. Okay, great. We can discuss once we get to Altair a bit of the planning stuff, but just wanted to give a quick update on that. Thanks to everyone for getting up early and or staying up late. Okay, let's run into client updates. We can start with Prism.
Yeah, hey guys, Terrence here. So the last 2 weeks, we have mostly been optimizing Altair. So mostly optimizing across the sync committee receiver side of things. And we made a decent progress on that. And unfortunately, this morning with the testnet, we had the issue where we were not able to propagate block to the peers. So it sounds like something to do with the peering related thing. We're still trying to figure out. So we'll give you guys an update once we figure out, and hopefully today. And
Quick question. Are you receiving blocks and attestations? Are you following the canonical chain? You just can't get your own blocks out?
so what we suspect is that we had a bug in the sync validation pipeline for the P2P. So we basically fail the sync committee object, which we should not be failing. Because of that, we started banning peers right away. So therefore, we don't have any group peers at the end.
Gotcha.
Yeah. And so other than that, mostly on the phase 0 side, we are enhancing our slasher. So we're working on basically the ability to backfill attestations once you sync to the head. So working on that. And then other than that, we're done with the E2 API implementation. So now just testing. So that's really exciting as well. And that's pretty much it. Thank you.
Thank you. And Lodestar. Oh, I don't know if we have anyone from Lodestar. Lodestar was on the DevNet launch this morning. I think they proposed the first block, and looks like they're following the head. Other than that, I'm sure they're working on light clients and other fun things. How about Grandine? Is that how you pronounce that?
Hi, so it's actually a Lithuanian word which is pronounced Grandinė. Can you try?
Got it, Grandina.
So okay, so this is orders from Grandinė team. So we had a small release with small fixes and some optimizations. In the last couple of weeks, we were working on the experiment that I talked last time. We are trying to run a couple of forks at the same time, and we found some interesting ideas that I would like to share during the merge discussion, which I believe will be later in this call. Is it correct?
Yes, we will. There's a couple discussion points Mikhail brought up, and we can discuss what you want to bring up then.
Okay, fantastic. Thanks. That's all from me.
Great. Thank you. Lighthouse.
Hello, Paul here. So we're pretty much up to date with Altair. We're still working on merging some of the features and optimizations, getting them from PRs merged into our unstable branch. We've also started working on optimizing Altair. We've done a few things. One of them, we've added a one-pass method to get all of the unslash participating indices and balances, and also the eligible indices. So we've been running that on the test nets, and it seems to be doing well so far. We've realized we've had to change some metrics in some of our validator inclusion APIs because Altair tracks attestations differently, so we don't necessarily know whether or not they attested. Before we knew, like, did they get an attestation in this epoch or not, and now we know, like, did they get a timely source attestation in. So we had to change some of our metrics and external facing APIs to reflect that better. It's not a big deal, but interesting thing that I imagine other clients will come across as well. We have been doing lots of upgrades to our network. We upgraded the C5 and the P2P packages, and done quite a fair bit of refactoring of various parts of it. So we're going to include that in our 1.5.0 release, which we've been working on really hard. There's been lots going on in Lighthouse actually to get this released out. It's going to be a big change to Lighthouse. So we're currently trying to get all the features finished for that, so we can move on to doing testing for it, and we'll probably cut some beta pre-release candidates as well, since it's such a big change. That's it from us.
Gotcha. And such a big change, this is a lot of the things underneath the hood, or will it expose big changes for end users?
Yeah, most of it is under the hood, kind of as it feels like it is always. But there's going to be a few features. Yeah, not a whole lot of like changing things, just kind of new features and lots of under the hood things.
Gotcha. Cool. And Nimbus.
Our focus has been on Altair as well. We've had to develop the code kind of on a hurry to participate in these test nets. So we are still trying to test it and improve it as we go along. There are some very few missing features, such as our validation is not entirely complete. And we still have a lot of progress to do on the light client sync side of things. Other than this, there has been some progress on the phase 0 features, such as weak subjectivity sync, which we have partially implemented, but we are missing features such as the block backfilling and pruning of the database to achieve a steady state operation with a fixed size database. Our REST API and validator client based on it is also another development track that we are actively working on. We've concluded tests involving running a combination such as a Lighthouse validator client with a Nimbus beacon node and vice versa. And this seems to be working. So we invite other teams that are already taking advantage of the REST API to try to test the compatibility with Nimbus.
Nice. Thank you. Teku.
Yeah, hi. We've been really polishing off the Altair stuff. So all our dev nets are shut down because got the official ones now, which is good. Been doing some profiling around that, just the last tweaks to the REST APIs, making sure they all align, and a bunch of testing around there has been the main things. User facing, there's a migration tool for moving archive nodes with the full state over to LevelDB without having to do a full resync, which is nice. Yeah, but that's about it for us, I think.
Great, thank you. And Mr. Daplion joined us. You want to give us a quick update on Lodestar?
Sure. Hi all. So we have updated our logs, polished all the ecosystem libraries. Things got out of date, and we've been working hard on providing meaningful examples, so everything is as usable as possible. We have been stress testing the node against many validators in preparation for the testnet that went quite well. We have also been working hard on improving attester performance with metrics and other little improvements. In the same vein, we optimized the gossip handlers, and we added an optimization to cache the signature domains once the fork info is known, which has been helping a lot reduce hashing. And we have continued more progress on our REST-based light client, how to init from a weak subjective state and how to generate and cache that information on the node side, so it's not extremely heavy memory-wise. That's it. Thank you.
Got it. Thank you. And congrats on being on the DevNet this morning.
Thank you.
And the first block. Okay, so moving on. We're moving on to most of discussion around everything is Altair, but we will specifically now discuss Altair. Alex, Xiaowei, myself, and some others spent a lot of time enhancing testing, and a lot of what came out in beta 1 yesterday was just enhanced test coverage. Sounds like everyone got those passing, which is good. I kind of hoped that we would hit a corner case and trip you up, but we didn't. We still have a little bit of stuff on our list to get on the testing infrastructure, some other corner cases and some more random test vector generation, and probably expect to see like a beta 2 with no feature adjustments in a week time. Beta, we moved from alpha to beta. This is everyone had been on a DevNet at that point, which means everyone had touched all the features and provided feedback as needed. So moving into beta, signaling things are firming up a bit. So that's that. Oh, also Jim, as you all know, did some analysis on the choice of the sync aggregator selection constant, and suggested upping that from 4 to 16, which was a good suggestion, and that's the only substantive change in beta 1. The testnets are on alpha 8, so that's the one difference. as Adrian mentioned, we could, on Monday, change that constant from 4 to 16. If we don't do it in a very coordinated way, we'll see the sync committees, some of that probably drop off a bit and have some scatteredness there, but everything else will still be live. So we can try that experiment Monday, Tuesday if y'all want. Planning. So 2 weeks ago, we said we were going to do a couple of DevNets, and we did. And we were going to say that if things went well, we wanted to target maybe the last week of July for, which is after ETHCC, for upgrading Piermont. As of this morning, we have at least one client that is still sorting out some issues on DevNet 1. So that is not a full 100% systems go, but I would like to open up for discussion on when we think is a good target for that Piermont fork, or if we should be discussing, some iterative DevNet launches. I know there's a decent amount of overhead each time we do this, so I kind of want to turn it over to you to get some opinions on timeline and path. Obviously, last week of July with Piermont would be probably aggressive given some of the issues we saw this morning, but we could talk about a week later, 2 weeks later, or we could wait and do a couple more DevNets before we set a date on that. Any burning opinions and thoughts on how we want to move forward on this?
I think the main concern I have right now is that we haven't seen the sync committee stuff working particularly well at all. 50 to 70% is the best we do at the moment in terms of we're getting signatures in there. I think we know the problems,
Right.
but I'd be quite keen to see it actually work. And
Okay.
We should be able to do 100% attestation effectiveness or inclusion, correct attestations, and pretty close to 100 signatures as well.
And when you say we know the problems, we think it is a mixture of, 1, Prism's offline currently, and 2, that choice of 4 rather than 16. So we're seeing non-aggregators on some of the subnets at least a significant amount of the time.
Yeah, I think so. There might still be some gossip problems. We are seeing signatures missing, but that might be the Prism nodes gone. So
right.
I'm hopeful that those 2 things you mentioned are all that's going wrong there.
Okay. Yeah. So I would tend to agree, which puts us testing this between now and 2 weeks from now. And there's 2 ways to do that. One is to shore up DevNet 1, and the other would be to launch another DevNet. Are we in favor of targeting the beta 1 updates for Monday, Tuesday? They don't have to be in a super coordinated measure. We just kind of have to set, okay, do it by the end of Tuesday, get your nodes updated with that one configuration value, and then we'll monitor what happens on Wednesday.
Sounds good to me.
Sounds good to me.
Okay.
Sounds good.
Is getting those nodes and releases updated by end of Tuesday so we can monitor on Wednesday? Is that reasonable? We're good on that timeline?
Yep.
Okay.
Yep.
Great. So let's do that. And then we'll take a look at what's going on, and then we'll make an informed decision on whether we want to do a DevNet launch the following week, maybe with more validators. And then we'll be here again in 2 weeks and can make a more informed decision on when to fork, if and when, and how to fork Piermont.
So yeah, that sounds good. Sorry, Dan, were you suggesting another testnet launch next week as well?
No, I'm suggesting we get these beta 1 updates, we do monitoring, and at the middle to end of next week, we can make a call on whether we want to do a DevNet launch the following week, or if DevNet 1 will serve our purposes for further testing.
That sounds pretty comfortable to me.
Sounds all right for us as well.
Okay.
Yep. That's good to us.
Okay. Cool. Great. I know there's a lot of continued work on monitoring, testing, fixing, improving Altair. So I suspect that's a lot that's going to happen the next couple of weeks, regardless of the beta 1 stuff. Is there anything else related to Altair that we'd like to discuss at this point?
I would just like to say that we're going to drop our DevNet 0 nodes soon. I think the other client devs are intending to as well.
Great. Perfect. Kill him. Okay. So we have a path forward. Hopefully someone wrote that down. We'll circle back and make sure that information is shared on some channels. And we will move on. Are there any research updates people would like to share today? Easy. Okay. So there were a handful of points. We did cancel the merge call this morning. There's not a ton of content there right now as everyone's working on London and Altair, but Mikhail did have a few points that he wanted to bring up today, and looks like we have plenty of time. Mikhail, would you like to go through these?
Thanks, Danny. Okay, so yeah, list is short. Yeah, the first one is the mixed hash for using it for RenDAO and exposing it in the EVM. For the context, we had the discussion where we've been discussing what field of the pre-merge mainnet block to use to feed the RenDAO into it. Like we had discussed two alternatives. One is the difficulty, and obviously in the difficulty case, we will not need to update the EVM context because the difficulty is exposed by the difficulty opcode. But it has other implications, like the difficulty is participating in the total difficulty computation and in the fork choice rule. And the other one is to use the mix hash, which is only participating in the verifying the fork puzzle, whether it's correct or not, and not used anywhere, if I understand correctly. And yeah, but in this case, we will have to expose the mix hash to the EVM and use it as the return value for the difficulty opcode. And Micah has like a particular proposal for this one. Micah, do you want to?
I have a quick question. Is sure. Mixed hash not exposed in the EVM today?
It's not exposed.
Okay.
Yeah.
And so this is kind of a compromise between getting randomness into the EVM through the difficulty opcode, but not accidentally having that value filter out into the other places that difficulty is used throughout the code base.
Right. Also, like the mixed hash is always 32 bytes. So if we just zero them, we can say like, yeah, and difficulties can be a 1 byte value if it's set to 0. So we'll save some space here as well.
Gotcha. Sorry, Micah, did you have some stuff? I didn't mean to cut you off.
No, not really. Just for those that didn't follow along with all core devs, in the Geth client, difficulty is internally managed as, I believe, an 80-bit value. And so there's some risk if we try to use difficulty, whereas mixhash, as Mikhail said, is 32 bytes always. So less risk on that front.
Right. And do you think it also reduces the risk of accidentally having longest chain rules and stuff filter in there because difficulty will always be 0 instead of random values?
So that part's unclear to me because if you're using difficulty at all for your longest chain rule, I feel like you're totally broken since you should be relying on the consensus client for that. So I'm not clear.
Well, you get to at least throw 0 in there, which would break your longest chain fork choice rule probably.
Is the idea that maybe a client accidentally has both proof of work longest chain and proof of stake longest chain running side by side, and this way we guarantee the proof of work won't work?
Yeah, if you get a 0 in there, you definitely guarantee that you're not that if you have bugs with you're accidentally using a longest chain rule, you're probably going to find it more quickly than if, say, you put in 1.
Yeah.
Sure, I guess.
Yeah,
I find that a dubious
I also
argument.
find this bug unlikely, but
Yes, but
Yeah, I think-
okay, sorry.
No, go ahead.
We should not consider it as a 1, right? As a constant value set to 1. But if we set a random there, it will be like 32 bytes, and it could be the case when the client has failed to switch to the new fork choice rule, but and still following the total difficulty rule, and it seems okay. Like, because the random is pretty huge value, it will overbeat any proof of work difficulty values. So
I mean, you'd also need to have a valid mix hash, right? It's like you have to have someone who's mining on this chain, and then a client who's also still following the old chain fork choice rule, but is also following the proof of stake consensus rule. Like, it seems like a really bizarre set of bugs to me.
Yeah, I think that's more. For me, it's more of an argument for doing 0 instead of 1, rather than the randomness stuff. But
I see.
Do you foresee any particular issue? I mean, I think this makes sense, especially because of the 32 byte constant size there.
Yeah.
Are there any issues you might see arise?
From my point of view, I think the 32 bytes, being able to save 31 bytes in the header is pretty significant. Like, we'd like to trim down the header, in a fork later, but it'd be nice if we can just from the get-go have a 31 byte shorter header than otherwise. And so that's convincing to me. I think the trade-off here is, do we deal with from a complexity standpoint, either we deal with the potential complexity and go Ethereum because they're using 80 bits for that 13th value or 7th value, whatever it is. Eighth value in the header, or do we deal with the complexity of having to touch the EVM and change what slot in the header that opcode points to?
Right.
So there's basically just 2 complexity choices we have to make here, and if they are deemed equal, then it feels like the space savings wins out. Mm-hmm. If one of them is deemed to be more complex overall, then it feels like the space saving may not be worth it.
Mm-hmm. On the way that the difficulty variable is,
because we can clean up the block header.
Sorry, you cut out and I started talking over you. I apologize. The way the difficulty value is, it can be a minimum of 1 byte. Is there a maximum?
So in the Geth code base specifically, 80 bits. So whatever, 10 bytes. Is that right? I think. Like, they store it internally. As far as the header is concerned, it's just RLP, and so it can be up to, I don't know, 40 billion bits or whatever it is.
Yeah. So do we also kind of cut a DOS vector out at its legs by using the constant 32 byte size?
What would the DOS vector be here?
Infinite RLP encoded byte size for difficulty.
Oh, yeah.
Or is that just all over the
Maybe,
place?
But I mean, I think technically, yeah, we've already got that problem everywhere. So, like, when you're RLP decoding this, like, you already have to deal with that because there are a bunch of there are a bunch of RLP encoded quantities in the block header.
Right.
And someone could create a block that, has those set to giant for any one of those. So I don't think there's any sort of new issues being brought up here,
Gotcha.
Nor will there be any that we are.
You already need to have sane limits.
Yeah, exactly. Your block header decoder needs to be able to deal with someone putting in a giant value for the length of these quantities.
Gotcha.
And I think by convention, we just assert that none of them will ever be more than 256 bits. So I suspect that most clients decode under that assumption.
Got it. Yeah, so I think, Mikhail, if we just get this written in a public place and probably source a little bit of more feedback on the execution layer side, we can find the right trade-off here.
Yeah, sounds good. We could probably draft a specification for this change, right? And discuss it.
Yeah.
Okay.
Okay, and then next, weak subjectivity checkpoint between the merge fork and terminal proof of work block. What's on your mind?
They could potentially be the case. Yeah, for the context, we have the merge happening in two like steps. First step is the merge fork on the beacon chain, which enables the logic that is required to embed the execution payload into the beacon chain. And the next step is the actual transition, which is signified by the proof of work chain reaching out the transition total difficulty. And we will have likely a week between these two events. It will give us some time to react if something bad happens at the merge fork. Yeah, the point about the weak subjectivity period here is that what if the weak subjectivity checkpoint happens between these two steps, between the merge fork and between the transition process? Then we will have to, first question is whether it's possible and whether we should even discuss this. And the second one, so let's.
A weak subjectivity checkpoint is really just something that's been finalized within the time period that you deem safe to load from. And so it certainly could happen. You can certainly choose something on that range unless it's deemed unsafe by our discussion and we figure out something around it. What do you see as an issue in using such a point?
Yeah, if it happens like between the fork and the transition process, the nodes the fresh nodes that starts with this weak subjectivity checkpoint will have to somehow compute the transition total difficulty or get it somewhere. We are not storing the transition total difficulty in the beacon state.
Got it.
So it will not be presented in the beacon state. We use like transition store for this purpose. And yeah, there are two options, whether we include it into these, whether we include the transition store into weak subjectivity data, which is I'm not sure about, or we include it into the beacon state, or we somehow prevent this checkpoint happening before the transition process.
Right, and remind me exactly how the difficulty is calculated dynamically. Is it the first ETH1 data included after the fork or something like that?
It's like, yeah, it's the ETH1 data that is presented in the beacon state during the upgrade to merge.
Right, and you
function.
can't historically compute that necessarily from starting in the middle unless you walk back the block tree and ask for a proof about the state at that time.
Right.
Okay. Right. I mean, the easiest thing is to, once that forks happen, serve weak subjectivity states at that fork point and not in between. And then once the transition's finalized, to only serve them after that point. There's also another point to bring up here is that there's not super robust standards on the serving of this right now, although everyone's been working on it with respect to clients, and there's a little bit of work on standards, but so we should probably evolve the two together. But I agree, it's probably simplest to avoid that week. It's also at a certain point, it's likely. Never mind. I was going to say it was unsafe to try to do the transition process not live later, but once things are finalized, you just will have a fork to follow from proof of stake, so you don't really worry about if things have been forking on proof of work after.
Yeah. Yeah, I was also wondering how clients plan to how clients do plan to work with these weak subjectivity checkpoints and serve the state. So it depends on our decision regarding this point. Depends on this as well.
Right. I'm okay writing this problem down and having this conversation over the next couple of months. I think we should highlight that it's pretty important for the weak subjectivity sync standards and a lot of the R&D that's been going on to really shore up prior to the merge.
Yeah, I agree completely.
Okay, does anybody else want to chime in on this discussion topic before we move on?
And a couple of questions. Just if something goes wrong in that 1 week, is it expected the clients will ship with the ability to cancel somehow, like through a command line flag, or is the expectation that during that week we hack out a fix and then get it delivered to everybody?
That's not yet been discussed. Do you have a strong opinion one way or the other?
A weak opinion that having it with a 1 week window is pretty tiny to dev a fix and get it shipped. So a weak preference for shipping with cancellation, but I don't know how complex that's going to be. And if the complexity is super high, maybe not worth it.
Right. And additionally, there's been discussion around shipping with whether we should ship with a terminal proof of work block manual override. So in the event that there's, say we never get to the total difficulty because there's some sort of attack on proof of work side, there's all sorts of forking and it just never gets there or something like that, the ability to manually as a community select a terminal proof of work block and just build from there. Both of those types of flags, I guess we should hash out.
Yeah, then we can, I don't know if we have this cancellation option built into the clients. I'm just thinking about whether it could be abused by anyone or accidentally trigger it or something like that.
Right. I mean, the cancellation option on the would be essentially for the beacon node 2, you could expose -- override terminal difficulty and put that at infinity, which would stall that would be able to use the same code path but update the constant to pretty much stall indefinitely.
Oh, that'd be nice. Less.
Okay. Put it on the to be discussed and hash out more list. Okay, and Mikhail, did you want to bring up that last point?
I don't know, actually. Yeah, let's just try to bring it up and see what happens.
I can give the context because I brought it up originally. So there's this notion of a terminal proof of work block. This is really, once you have a canonical chain going from proof of work to proof of stake, it is the last proof of work block that made it in there. And there's rules on what this can be to really trigger the transition. Currently, the rule is that terminal proof of work block must be greater than a total difficulty. That total difficulty is calculated prior and just a constant in the chain. When I was working on some other documentation, I assumed that we had this condition where not only must that terminal proof of work block be greater than the target total difficulty, but that its parent greater than or equal to but its parent must be less. And this would give less optionality on the selection of that block. It must be like a block on the cusp of transitioning into that terminal proof of work difficulty. And it allows, if you wanted to, on the proof of work client, to really reject a lot of incoming block gossip during the transition period and make things potentially safer or potentially just less surface for variance to happen. And from that perspective, it made sense to me to add that additional condition. But Mikhail brought up the fact that you could have a potential application layer liveness or even reversion issues. So take in the extreme, we hit the minimum terminal proof of work total difficulty value on the proof of work chain, but the beacon chain is not live for 2 epochs. And then the beacon chain comes on, and so the proof of work chain continues to be built. And then the beacon chain all of a sudden comes back online live. It's been 12 minutes and must then select the terminal proof of work block from 12 minutes ago because of the way that rule was constructed. And so the proof of stake chain would then build from 12 minutes ago, take over, override the previous proof of work fork choice, and essentially do a 12-minute reversion. That was the counter to what I thought was a reasonable proposal. I think we wanted to present it here. Happy to discuss it here if people want. It's kind of a lot of moving parts, but mainly just wanted to get it out as a point of R&D and discussion.
If the proof of work clients rejected blocks that went beyond that, wouldn't that resolve the issue?
Well, there'd be
build the proof of work chain further.
So there'd be 2 issues there. I mean, so there's 2. If you leave that rule in there, there's 2 ways it could go. You could do rejection, so you have liveness failure, or you could build, and then you have the reversion issue. I guess if you have the rule in there, you'd rather the liveness.
Sorry, but I mean, you're saying you have a liveness failure.
Sorry.
And because the beacon chain is offline, right? I mean, you will have that in the future too. Like,
right. I mean, that's normal.
If the beacon chain is offline, then you will have. So why should we make the special rule so that at that particular point, the proof of work chain could continue?
Well, you might. Right. You might make the rule such that you just don't have the hiccup, because if in 2 epochs they could select what is the highest difficulty for the first proof of stake block after the chain, then you just have a continuous chain, but you might open up attack surface. I don't know. I mean, I guess that would maybe incentivize proof of work to DOS or break the beacon chain for as long as possible at the transition epoch, which is maybe a bad incentive.
Right. So, I mean, I think there should just be 1 block. Like, there shouldn't be, we shouldn't try to select a later block.
Right.
And I mean, if the beacon chain is offline, then, like, I mean, you're trying to get a higher service level for the transition time than we will have at any later time. Basically, like, if either of the 2 is online, it should still work. But that's not true before, and that's not true after. So why should it be true at the transition height?
Yeah, I think I agree with you, and that especially the fact that all of a sudden, if miners can figure out how to take down the beacon chain, they can mine for longer. That's not. I don't think that's a good incentive.
Like one of my concerns is that if we want to enforce this more strict condition, we will have to add more rules, and if we want to stop gossiping blocks above the terminal blocks, the terminal block candidates, so we will have to also introduce this restriction on the in the gossip layer. In the block.
Wait, but
functionality.
Why? I mean, that doesn't matter if they're gossip. Like, as long as they're not. I mean,
well, incorporated into what the execution layer sees as its canonical chain, whether it's gossiped or
so
not.
they shouldn't.
But you'd still have to.
But I mean, I mean, the Eth2.0 client at the block height that we're deciding has to switch consensus, right?
Right, but
it has to do that either way.
The Eth1 client doesn't know the transition total difficulty currently, because that's calculated dynamically in the beacon chain at the beacon chain fork, and then the transition, the override on the fork choice on the execution layer right now is actually just being communicated that there's a proof of stake block,
Right.
So there's a little bit of complexity on the communication.
That doesn't sound safe. That doesn't sound safe to me, because that means there's a race condition where there could be another proof of work block, and some people still follow it, and only later it gets communicated to the beacon client that actually that block was never valid.
Well, it's an override on the fork choice. So essentially, it's any.
Yeah, I'm
any
just
proof of
saying
stake
there's a race condition there, like in that, because like for example, imagine someone is running these two, and at the transition, their ETH2 client goes down, because I mean that's actually not unlikely at all. Like, because like I mean this is like the biggest fork that we've potentially ever had, right? So like, what if some ETH2 client crashes at the transition height? Then all the ETH1 clients that are connected to this particular client will just keep working with proof of work.
Yeah.
So that just doesn't seem safe to me. Like, it can't be that the ETH1 client needs to wait for an ETH2 signal to change their consensus.
I'm not necessarily. I see what you're saying, and I'm not claiming that it is safe. I'm just claiming the way that communication protocol works right now is the delivery of that proof of stake block is really the triggering of this is your fork choice now.
And it feels like maybe the ETH2 client needs a way to tell the ETH1 client, hey, like, this is the height at which you stop.
Which it could, and it could a week prior, given the way things are configured. That's just additional complexity in that communication, kind of single-use communication protocol. But I think definitely worth discussing after this.
I tend to agree with Dankred there. If the proof of work client continues on proof of work chain for too long, eventually it will not be able to reorg back to the proper transition.
Right.
And so if it goes down for, half a day or whatever, which is not unreasonable, then you're stuck. Like, you have to resync everything.
Right. Especially, because we're looking at, I think each proof of work client has different values for maximum reorg, but they're not incredibly deep.
Yep.
Yeah, so we might probably need to communicate this transition total difficulty down to the execution client, right? To avoid these kind of cases.
Yeah, it does seem safer.
Okay. Yeah, that's a good point, actually.
Okay. And yeah, I think intuitively, I think it makes sense that once the beacon chain is supposed to take over, we should, and it has a liveness failure, we should act as though the beacon chain is taken over and there's a liveness failure.
Yep. There could be a slight liveness failure due to partitioning the proof of work network, like a kind of temporal partitioning when the block is not fully propagated, but that should be recovered in a block.
Okay. So I think we have a little bit of work to do to think through a couple of these things, and also get a bit more concrete proposal maybe prior to all core devs next week for the mix hash, continuing mix hash discussion. Anything else on Mikhail's points before we move on? Okay. So Alias, you had something you wanted to bring up with respect to merge and your client investigations.
Yeah, so this was built on top of my previous ideas of running two runtimes. So we introduced a term that is called a fork time. It's a kind of runtime that contains everything needed to run a fork except the shared components. So, for example, API endpoint is a shared component. It's one instance for all the fork times. So basically, a client is able to run multiple forks at the same time. So we are thinking that this approach could be useful in a merge. So the main motivation is that during the merge, there could be some terrible incidents that we may not thought about, and the code is not ready to handle it, basically. So if client is using two fork times, let's say if we fork from Altair, probably not, but let's say we fork merge from the Altair. So instead of a regular hard forking Altair and hoping that everything will go well, we could have two runtimes, and these fork times, which one's running the Altair. Basically, there is no interruption, and the Altair is running after the merge. And another fork time is trying to do a proper merge with a proof of work chain. So if the merge is successful, then we have a social consensus where we just stop building on Altair and then basically forget about that. And if the merge is not successful, then we can basically drop this attempt and do again a social consensus on the next time when we will try to attempt again after we fix the cases which broke the first attempt. So this also would decrease the motivation for adversaries to try to do a coordinated attack, because we just publicly say that we are going to attempt to merge as much as it needs, as it gets successful. So this is a kind of a very high level approach, and this is, for me, it looks like it's just a safer way comparing to the current designs, where basically the Altair or another fork which will be used to fork for the merge. So this is just a safer way, as we still will be running the old fork, and we can always build and make again the attempts to merge on that older fork. Does that make sense for you?
So there's a lot there. I think one, I am excited to see someone experiment with the multiple runtimes to handle forks. But I think the second thing is that most clients don't run like this, and it might introduce significant complexity to try to get them to run like that, and make it a dependency on the fork. And then I think the main pushback that is probably worth pondering is that failure of a fork is probably hard to define. It's probably very difficult to codify. So you could have a social consensus where you like run -- revert and go back to the chain that was still being built in parallel. But often, I think more often than not, a failure in a fork would look more like emergency fixes and working through it and getting to a success state rather than an abort. And defining what an abort is might be difficult.
Okay, so yeah, I think I get your idea, but the key thing for me is that as already was mentioned even in this call, that this fork is probably going to be one of the most complex forks in Ethereum. So I don't know. I mean, yeah. I think this is a great argument that it brings complexity, really big complexity, and some clients may be really hard to change to this approach. But on the other hand, I really see that well, for me, it at least looks like it's a safer way to try to fork merge.
Any other reactions?
So is the idea that you continue to build blocks on the old chain and the new chain, so you double up what you were doing before?
Yeah, but this is this question for more that the client's already doing a lot of computation, and this will be a double computation, and that's a bad thing, or your idea is different?
It would be double computation, double database, and double bandwidth, especially on those attestation topics, which on our resource constrained devices, which there are mainnet validators on relatively resource constrained devices, I think that's certainly probably breaking a promise of by going from 100 to 200% or doubling resource requirements for a stretch of a week or two.
Okay.
I think there's something to be.
Okay, go ahead.
I was just going to say, I think there's something to be said as well for just committing to a fork, you know, just testing it, putting all our energy into making sure that that fork goes well, as opposed to spreading a bunch of energy as to trying to back ourselves up in the case of failure.
Yeah, and I think that plays a little bit into my worry, which is even defining failure. And I think that 95% of failure cases we would work through dynamically and not do a revert. And so then you end up planning for and doing significant development for, my estimate is maybe a bad estimate, but for those 5% of cases, failure cases. I don't know. We're all very afraid of complexity.
Yeah, that was the idea, to try to make it a bit more safer than it is now.
Right. Adrian?
Yeah, I was just going to say some of the most disastrous code and difficult code to write is actually failover code, when you're running two things at once and then trying to decide which one's the real one and switch between them. It gets real messy real fast.
Okay. Any other comments on this? I would. I mean, it's certainly an interesting thing to discuss, and maybe further discussion can happen on ETH R&D if people are interested in chatting more about it.
Yeah, I think a proper write-up would be quite useful. It's hard to take it all in on a call at 1 a.m. There's potentially ideas in there that we could learn from, and so a good write-up would be useful.
And Salius, based off of your past 2 weeks of investigation of forking, does it look like you will be utilizing this multi-runtime infrastructure?
Yeah, so basically we will try that for LTR, but the problem is that it's a major change in the code base, as the code base was not designed to run 2 fork times once. But this week we got the code compiled, which is a big achievement in Rust language. But I think it will take a couple of weeks or maybe even a month, as it's a bit hard to estimate this, to get the code actually working. And I think after that, maybe I can come back with our, let's say, more solid findings from this approach. Yeah, maybe there is a chance that during this attempt to do this fork time thing, we'll just figure out that it's not worth the effort. It could be so, but otherwise we will try to do that for the Altair. So the phase 0, if everything will go great, then phase 0 will run in 1 fork time, and the Altair will run in another fork time.
Cool. Well, why don't you keep us updated over the next month and a half on that R&D project, and we can kind of keep the discussion going.
Definitely. Yeah, definitely.
Cool. Okay, let us move on. I think we did some spec discussion with respect to the merge. Is there anything other in spec-wise people want to talk about today? Okay. And any other discussion points or closing remarks?
The sync committees are already looking better on the DevNet. Prism seems to be producing blocks and inclusion rates are as high as 97, 98%.
On the sync committees?
In fact, that block has 100%. So that's really promising, yeah.
Oh, that's great. So I would suspect on the order of the probability of not having aggregators on different subnets from Jim's analysis, which I think is in a spreadsheet that Xiaowei put out, we should probably see some like drop-offs in subcommittee sections as we monitor over the course of hours and days, which might be interesting.
Yeah, we are definitely seeing that.
Okay, cool. And are they in contiguous blocks?
So we could spot them even with Prism out. You'd see the contiguous blocks of zeros.
Okay. Good.
And we're seeing the same kind of spiky thing, so I suspect it's still happening occasionally.
Okay.
But generally much better.
So validation looks like validation of what we see as the issues, and we will patch it up and monitor on Wednesday.
Yep,
by Wednesday. All right, great. Thank you, everyone. Congrats on the DevNet launch. Progress. Talk to you all soon.
Thanks all.
Thanks all.
Bye.
Thanks everybody.
Bye, everyone.